Hey, what's up guys? My name is Saurav and this is my YouTube channel Data Science Novice. So if you are new to my YouTube channel, please do like and subscribe. Your efforts are massively appreciated. So this is another video from the lecture series on data pre-processing techniques, where we are going to learn different techniques that one can use for pre-processing the data for the machine learning algorithms. So in the previous video, we talked about complete case analysis, which is used for treating the missing values in the data. So in this video, we are going to do the Python implementation of this technique. And the data we are going to use is advanced linear regression computation data, which is quite famous one. And if you want to know more about the data, I have provided the link in the description box. From there, you can download the dataset as well. And throughout this lecture series, we are going to use that data only. And the reason being, this dataset is very close to real world datasets. It's kind of messy and we have lots of cleaning to do before feeding it to the algorithms. So enough with the talks, let's jump to the Jupyter notebook to do the Python implementation. So I have written the code for some of these steps. So in the first step, we are importing all the libraries. Next, we are loading the data using pandas.csv method since it's a CSV file. Now let's peek into the dataset. And here we see that we have a dataset which is mixed of categorical and numerical variable, which is a good thing because in real world we have this kind of dataset where we have the numerical variables as well as categorical variables. And in the later part of this series, we will see that how we can deal with this categorical variable by doing some kind of categorical encoding. And by the way, I have a project on advanced linear regression where I have used all sorts of data cleaning techniques and applied some advanced algorithms, so you can watch all those videos as well. Next, we are going to separate the variable based on the missing values they have. So first we are going to create an empty list in which we are going to store the variables. And next we are running a for loop on the column list. So this data.columns return a list of all the variables that data contains. So we are iterating over that list. And inside the loop, we are doing a test. That is, if the sum of null values is greater than 0, which means that if the column has any missing values, then we are going to append that column into the empty list that we created earlier. And like that, we will have all the variables which have missing values. In the next code, we are just making sure that all the selected variables have missing values. So here you can see the percentage of missing values in each column. So like this, you can always keep a separate list of variables because it's easier and convenient to deal with the missing value there. Now next we are going to create a list on which we will apply the complete case analysis. And the reason being, we cannot apply this technique on all these columns because we may end up losing 90% of the data. So my rule of thumb is if percentage of missing values is less than 5%, then I'm going to apply this technique on those columns only. So first we are going to create a variable list by the name var_cc, which stands for variable complete case analysis. And here we are going to use list comprehension. So everything is going to be same, but now we are going to change the condition here. So earlier it was greater than 0. Now it is going to be less than 0.05. That gives us all the variable which satisfy this condition. So now this list contains two types of variable. The first one which have no missing values and the other ones which have missing values but less than 5%. So here I am finding out the mean. You can do that sum and then divide it by the length of the dataset, which is same thing. And now let's check whether we have selected the right set of variables. So I'm going to copy paste the code and then we are going to change the list name here. And here you can see that we have this column which have no missing values. And in between we might have some columns which have missing values. Next, we are going to apply the complete case analysis technique, that is dropping the missing values. And we are going to store it into another data frame just to do the further analysis. So we call the original data, then we pass the CCA list, and then we call the drop NA method to drop the values. So now let's check how much data is lost. And for this, we just have to print out the shape of each data frames. So earlier we had 1460 observation, and after dropping the values, we are left with 1412 observation. So it is safe to say that we are not losing much information, or you can say data. So the first thing that we have consolidated is that we are not losing much information. Now the next thing that we have to make sure is that other variable distributions are not changing. So for that we are going to plot some graphs. So basically we are going to plot three graphs. The first one will be the graph with no missing values dropped. Second graph will be the missing values drop, and the final will be the overlap of these two graphs, which will give us the idea that how much distribution is changing, and accordingly we can plan whether we should apply this technique or not. Since the code is quite lengthy, I'm going to copy paste it here and explain you what's happening in each section of the code. So here is the code and you can copy paste it from the GitHub link that I have provided. Don't try to write it down because chances are high that you may end up making some typos, but it's quite a simple one. So first we are setting the plot size and it will be given by the user during the function call. So here we are creating three subplots. In the first one, we are just creating the histogram for the data in which we have not dropped any missing values. And in the second one, we are plotting the data where we have dropped the missing values. And in the last block, we are just overlapping both the histograms. Next, we are going to apply this function on any variable, but most preferably apply this on the variable which does not have any missing values. And the reason being, this will help us understand that how the distribution of other variables changes with this technique. So if the change is significant, we have to use some different techniques. We cannot use this one. So now let's quickly call the function. So first we have to pass the actual data, then we have to pass the CCA data, and then we have to give the variable name. So you can choose any variable which has no missing value. And finally, we have to give the figure size. So let's run this cell. And here we are getting an error. So let me check where we are making mistake. Okay, so this is due to the wrong variable name. So let me correct it. And here we see the three plots we were talking about. So the first plot is an orange plot which comes from the actual data or data with missing values. The next plot is the green plot which comes from the data after applying CCA technique. And finally, we have another histogram which is an overlap of the two histograms. So from here, what we can say? So by looking at the third graph, it appears that data distribution doesn't change much because when we overlap these two histograms, we don't see much change. Hence, it is safe to say that we can apply this technique because neither we are losing the data which we saw previously, and the second thing is that the data distribution doesn't change, which we can see from this graph. So far, we are able to check that change in distribution in case of continuous variable. But how we can do the same analysis in case of discrete variable or categorical variable? So in this case, we have to check the count of each values taken by the column. So we are going to compare the counts before applying the technique and after applying this technique. And the code is going to be very similar. So I have already written this code. So I'm just going to copy paste here and we will walk through it. So this is the code that we are going to use and you can see that it is very similar to the previous one. So in the first block, we are creating a count plot for the data which has missing values. And in the second block, we are creating count plot for the data which does not have any missing values. So now let's quickly plot the graphs and the parameters are going to be the same. Just make sure here we are going to pass a categorical variable, else we will get an error. And now here we see two distribution plot for the same variable. And if we try to compare the count, we can see that the counts are almost same. We see that data distribution is not changing. It's changing, but it's not changing that much. So when we say that data distribution change, in this case, focus on orange and green bar only. In the first graph, the height of orange bar is greater than the green bar, means the count is greater. And the same trend is followed even after dropping the missing values. Had it been the case that the orange bar height is less than the green bar, then we might not have applied this technique. So now you can see that we can't just apply the complete case analysis without doing this kind of analysis. And now you must have understood that why we call this technique complete case analysis. So that's all about this technique, and I'll see you in the next video with a new technique. So if you're new to the channel, a subscribe is highly appreciated. So see you in the next video. Till then, bye, stay safe and wear a mask.